Hey everybody, I am Shikhar Patel. Me and my team worked on a project that is Perclias AI, and this is the platform how it looks like. So we have the login over here, and similarly, a user can sign up as well. So I already created the user over here, and I would be just simply try to log in. So user in this case is Aditya, and I would be entering the password and click on the login button. So once a doctor who is registered on our platform would be logging in, he can first see the patient management tab. So over here, he can search for a patient, enter the patient details, and also edit the patient details as per his or her willingness. So let's say we want to search up a specific patient which we created. So here you can see the details of the patient. And now let's move on to the uh, next portion, that is the Perclias AI. So this is the audio transcribing and this summary generating application. So here we have the two features. One, a doctor can record the audio which has been taking place in the front of patient, and the other option which is available is to upload the audio. So as per the in order to save the time, we already have a audio file. So I would be just
Good morning.
uploading this
How
file.
can I assist you today? Hi, doctor. I'm Michael Thompson, medical instructor, a verse in the joint.
So I would be now uploading this file over here and would be generating the transcription out of it, and also would be trying to generate the entire summary for the whole sort of conversation.
Patient name, Michael Thompson. Medical history, diagnosed with rheumatoid arthritis about 5 years ago. Background, experiencing severe joint pains and stiffness, especially in knees and hips. Previous medications, methotrexate and prednisone. Test results, elevated inflammatory.
So here you can see a doctor can simply edit the note if he finds that some mishappenings are over here, or he want to change some other things. So he can do it over here. And let's say the name of the patient is Michelle Thompson, and we are just entering 01 over here. And this entire note would be saved in the S3 bucket.
Patient, Michael Thompson.
एक मिनट रुक।
Now you can see that the edited note was been saved up in the S3 bucket with this specific name. Now we can move on to the next step, that is the diagnosis. So now we would be uploading a specific image in order to figure out like what all things could be analyzed from the image. So over here, an image has been shown showing the joint pain, and entire summary would be generated from the specific image and would be showed up on the screen. So here you can see that medical image analysis, knee X-ray, and the detailed analysis for the same, the finding reports, and the recommended next steps which a patient can follow. And apart from that, some treatment suggestions are been also been showed up. Now we would be generating the next step of procedure, that is the medication recommendation. So we used pinecone embeddings, and also we scraped data from multiple sources, and we had stored the vector data into the pinecone, and through that we would be generating the medical recommendation, remedies, and what all possible disease which a patient might be facing from. And here you can see the description, symptoms, home remedies, medication, and treatment, and all the five possible disease which the patient might be suffering from. So this was our entire application, and this is our about page. And yeah, you can just simply click on log out in order to log out from the application. And now Shubh would be explaining our architecture diagram and also his part of airflow.
Thank you. Thank you, Shikhar, for showing the demo. And now coming on to the architecture diagram. So we have tried to make the architecture diagram as simple as possible. So what we have implemented here is the doctor can log in through the UI through Firebase, and then the first option which the doctor gets is to have a conversation with the patient, and that is recorded and it's converted to text via OpenAI Whisper, and that text is summarized via OpenAI to summary. So basically, it's a short summary about the conversation of a patient and a doctor. And now coming on to the medication part, we have tried to automate the process as much as possible. So what we have done is we have web scraped data from a government medical encyclopedia. We have validated that data. We have loaded the data into Snowflake, and then we have posted into Pinecone. And through the Pinecone vector embeddings and the summary of the patient which was generated, we are able to generate the correct medications for the patient, which are like five most top probable medications as mentioned by Shikhar. And we have one more feature which Shikhar mentioned before, which is a doctor can upload an image of a patient's health condition, and that we would be able to get the patient details, whatever they are suffering from, or whatever their condition speaks about. Now coming on to the code, so I have done web scraping using Beautiful Soup and Selenium. So first I set up the driver, which is a headless driver. So what it does is it runs in your background, and uh, it tries to scrape all the web pages data. So the second function is scrape content, which scrape the heading, the content of that particular website, and the get all links function iterates over different links through A to Z in the medical encyclopedia website, which is Medline. And then it writes everything on the CSV, which the file path I have defined here. And coming on to validations. So I have made validations in such a format so that the conditions which are met are in such a way that the data is consistent and accurate. So I have like made sure that the minimum length of title should be 3 and the maximum length should be 100, and the content should have a minimum length of 500, so to have accurate results. And I have tried to validate that data using this Python script, and then I have like tested other use cases as well with this script, whether this script is valid or not. Coming on to the Snowflake part, so the data which is being validated is then pushed into Snowflake. After it is pushed into Snowflake, uh, basically it is then process to Pinecone. But before that, I would like to say that the whole process is automized by Airflow. So we have defined the task here through Airflow. The first is scraping task, then validation task, then load data to Snowflake, and then the Pinecone task. I would like to show you some snippets of the Airflow DAG which we run. So the Airflow DAG took us like 40 minutes to run the whole process, and it doesn't include the embedding part. It just includes the pre-process part just before pushing into Pinecone. So here are the snapshots for that. Okay.
Now Aditya would be explaining the remaining part.
Hi, all. Like my teammates have explained, we are at the stage where the data was pushed into Snowflake. So my part here comes in embedding Snowflake data into Pinecone and then vectorize it. So for that, I have fetched the data from Snowflake from the table Shubha has created and pushed into Snowflake. And then I've initialized the Pinecone with my Pinecone API keys and OpenAI keys. And then I have chunked the data because we had a large data and I had to chunk it. I put the chunk size as 512 because uh, that would optimize our RAG collection and RAG searching. And I put the chunk overlap as 96. Usually we felt it is a good practice to put the chunk size around 15 to 18% for the chunk size, because this would help the model to train better and give an optimized result. Once the data is chunked, we were passing the chunk data to the embeddings, where I've written a generate embeddings function using the model text3 small because we wanted to optimize on the cost and the high memory part. And then once the data is embedded, since we had the data in two columns as title and content in Snowflake, I've combined it into one single column so that the data could be embedded properly. And at the last stage, I was just checking if the index already exists or not in the Pinecone. If the index exists, it would delete and create a new index. And then I've pushed each and every embedding which have been generated into the Pinecone database. So if you can check here, this is the Pinecone database which we got created, and this was the data which got pushed. So coming to the next stage where I was working on is the RAGs for the medication analysis. For that, firstly, like Shikhar was explaining, the patient's symptoms were getting stored in S3. So I had to retrieve the file from S3 and then extract the symptoms from the extracted text. So that is where this function comes into place. And the second function is for generating the diagnosis report, which Shikhar showed at the last, where once we select the patient name, the whole automated diagnosis report would be generated with the top 5 possible diseases, because we gave the K nearest as 5. And then this is where the RAG logic comes up. I have given the AWS keys in here. And then I'm connecting to the Pinecone here as usual, and then extracting symptoms using the above given logic. Because we have to compare the symptoms with the knowledge base which we created before, I was even vectorizing the symptoms using LangChain. And then I clubbed all the symptoms using the NumPy mean, so that there's no outliers here and there. And once all that thing is done, I've written a query which searches for the symptoms vectors with the Pinecone vectors. And then all the matching this thing is being generated and is shown in the report. Thank you.